This is the final simple machine, the screw, located in 1.1.1. The screw is an inclined plane wrapped helically around a cylinder, and it is forming a pathway or a pitch. This is used to turn rotational energy into linear motion. So you're going to take a spinning object, such as twisting a wrench, to cause two things to come together. They have a huge mechanical advantage, much larger than what you've seen earlier. And much of that energy is lost due to friction. But before we can talk about screws and their math, what we need to know is talking about the actual screw itself and some of the specifics of a screw. In screws, we have this number. Every single screw has a set of numbers and letters associated with it. The first one is its diameter. In this case, it's in inches. This one is its pitch, its threads per inch. And NC describes what kind of thread it is. So we have in the United States, national coarse or national fine. So those are the two different types. That 13 represents 13 threads per inch. That means means that the distance between this is 1/13 of an inch. An effort arm deals with how the distance of you. Now, if you were to put this on with your finger, the effort arm would be the diameter of the head. But if you are using a wrench, you would need to include the wrench's length into it. And again, the diameter, which is this 1/2, is the diameter of the actual bolt. So how far will a screw with a 13 threads per inch move linearly if it's turned one rotation? 1/13 of an inch. The IMA is then the distance effort over the distance of resistance, and that effort is the circumference of your moving of that wrench. So its resistance, though, is going to be a linear. It's moving one of those thread counts, the distance between the threads. So that would be its pitch. So in this case, the circumference, which is 2 pi r, over its pitch. So what I want you to do is calculate what is the IMA for a screw in the above problem if it has a 8-inch long wrench used to move it in. So it's 2 times pi times 8 over its pitch, which is 1/20. So that's going to calculate 1005.31, or rounded to 1,000. This is a huge mechanical advantage. Now we look at the AMA. Again, the AMA is looking at resistance, your 1,200 pounds of force that is pulling the two pieces of material together, compared to your effort of how much pounds you're pushing into it, which is 35 pounds. You take 1,200 divided by 35, and you get an AMA of 34. Calculate the efficiency of this now. The efficiency is, again, 34 over 1,000 times 100, and that's going to give you 3.4%. Why is this so low? This is due to the friction. I hope this helped, and if you have further questions, go ahead and ask your teacher.